Good morning, students, and good morning, parents. Welcome to Edistar International School. You are watching Class 5 Mathematics, Chapter number 6 Factors and Multiples, Part 4. We have learned in the last class about divisibility rules. The divisibility rule of 2, 3, 4, 5, 6, 8, 9, 10, 11. These rules are going to help us to find HCF and LCM. So let us study about find the common factors of 20 and 45, then find their HCF. So now I am going to find the factors of 20 and 45. So solution, factors of 20 we are going to find. So first one, 120s are 20. What is common for all those numbers? So 1 is a factor for all those numbers. So 120s are 20. So 1 is a factor and 20 is a factor. So 1 and 20 you write at last. And next go with the 2 table. So last 0 is there. So it is divisible by 2. So it is coming in 2 table also. So how much? 2 tens are 20. So 2 is a factor and 10 is the another one factor. And go with the third table. It is odd number but is not there. 20 is not there in third table. So 1 is divisible by 3. So 3 is not a factor. And then move to the fourth table. So fourth table 20 is coming, isn't it? So what you multiply by 4 you will get 25. 4 5s are 20. So 4 is the one more factor and 5 is another one factor. Then last move to the 5 table. So it is also having 5 4s are 20, isn't it? So again, the repeat 4 and 5 repeatedly coming means you have to stop to find. So write remaining factors and all. 120s are 20, 2 10s are 20, 4 5s are 20. So what and all missing remaining factors? 5, 10, 20. Okay, now you see here 120s are 20, 2 10s are 20, 4 5s are 20. So here having 6 factors for 20. 45. First I go with the 1 table. So 145 is 45. So write 1 at first and 45 right at last. Okay, and go with the 2 table. You can apply here divisibility rule. See here, we can use divisibility rule to find easily. So the last ones place we have 5, that is odd number. It is not divisible by 2. So 2 is not a factor of 45. Then go with the 3 table. The divisibility rule you can apply here. The rule of 3, sum of all the digits. Sum of all the digits you have to add the 2 digits. 4 plus 5 how much? 9. So 9 it is coming in 3 table. So it is divisible by 3. So 3 is the factor. And 3 15s are 45. So 3 is a factor and 15 is another one factor. The 15 you can write at last. And go with the 4. The 4 that is even number. So when you multiply by any other number you will get even product only now. But we have here 45. So the 45 that is odd number. So it is not divisible by 4. Move with the 5 table. So you see here in the last ones place we have 5. So it is divisible by 5. So the 45 is coming in 5 table also. So 5 9s are 45. So 5 and 9 is the factor. And 6, 7, 8 is not possible. You can apply the divisibility rule here. So that is not possible. And 9 5s are 45. So the 9 and 5 again it is repeating. So you can stop to find the values. So 9 5s are 45. And what will come? 3 15s are 45 will come. So 15 one of the factor and last 45 is the factor. So you can check once again. 145 is 45. 3 15s are 45 and 5 9s are 45. We are having 6 factors for 20 and 6 factors for 45. So among that, which is the common factors here? Same number. In factor 1 is there and factor 45 1 is there. So both are common factor. So I am circled that number alone. And next 2 is not there. 4 No, here 5, yes, 5 here, both numbers having 5 factor. So I am going to circle that two factors also. So remaining and all 1, 1 only, no common factor. So which is the common factor of 20 and 45? 1 and 5 alone common factors. Okay, now among that, which is the greatest common factor? I am 1 and 5. Among the two numbers, which is the greatest number? That is the HCF. So which is greatest here? 5. 5 is the HCF. Then I'm going to explain the next one method. Find the HCF of 48, 54, 90 by prime factoration method. Already we have studied in the last class prime factoration method. In that we have studied two methods, one for factor tree method, another one for short division method. But when the question is asking like that, find the HCF of this number by prime factoration, means if they mention the prime factoration means you should use only the short division method. If they ask use prime factoration method means you have to use only the short division method. Now I am going to explain that. Now I am taking only the 48 alone. So that I am going to divide. So now you see here, while dividing the values, you should use only the prime number. Should not use any other composite number. If you use composite number means you will get the wrong answer. So better you had already we have studied the prime numbers, isn't it? So use the prime numbers alone to divide the values. Now you see here, what number it is? Even number. Even number means you have to use only the even prime number. Which is the even prime number? Only one number is there, that is 2. So use 2 to divide the values. So I am writing 2. Okay. Into how many times of 2's are there in 4? First number I am taking 4. How many 2's are there in 4? 2 times are there. So write 2. And how many times are 2's are there in 8? 4 times. So 24. So 24 is the answer. So again you are getting the even number. Even number means you have to use again the even prime number 2. So I'm going to divide again the same number. 24 is a composite number. You have to divide the values up to getting 1. Okay. Now divide the value again. Otherwise you have to divide the number separately. So how many times of 2's are there? Only 1 time. And how many 2's are there in 4? 2 times, totally 12. So you are getting 12 answer. Okay. 12 is the composite number. So again we want to divide the values by 2. Okay. So I am taking 2 again. How many times of 2's are there in 12? 6 times. So write 6. Then 6 is the even number. So again I am using 2. How many times of 2's are there in 6? 3 times. So 3 you have to write. Okay. So you are getting 3. 3 is a prime number. So whether you want to divide the value, that number means use the same number 3. So I am going to use the 3 to divide the value by 3. Okay. So 3. How many times are 3's are there in 3? Only 1 time. So write 1. Okay, you have completed the first part. And next number what do we have? 54. That we want to write. 54. Now you see here what number it is? Even number or number? Even number. Even number means you have to use only 2, number 2. So divide the value separately. What quotient you are getting, that quotient you have to take and write at the bottom of the number. Okay, so I'm going to divide the value directly. So 2, how many times of 2's are there in 5? 2 times 2 to 4. So 2 times are there. 2 I'm going to write. And in 5 we subtracted 4 means you have only 1 remainder. That remainder write before 4. So the 4 becomes 14. So 7 you have. Okay. How many times of 2's are there in 14? 7. So 27. Then now you see here 7. 7 is the AND number. So it is not divisible by 2. So go with the 3. So it is coming in 3 table. 3 is a prime number, no. So think about the third table. How many times of 3's are there in 27? Totally 9 times are there. Again the 9, it is a composite number. So which prime number is to divide the value? As 3. So you have to write 3. How many times of 3s are there? 3 times 3. The same 3 used to divide the value. You will get 1. Okay. Then you take and write 90. So now you see here the last one's place. 0 is there. That 0 is divisible by 2 as well as 5. So you go with the 2 or 5. That is your wish. Okay. So I am taking 2 alone. And how many times of 2s are there in 90? As 45 times. Okay. So last what number is there? 5 is there. That used to divide by 5. Otherwise 3 also possible. Sum of 3 digit, 2 digit, how much? 4 plus 5, 9. So 9 is possible now, divided by 3. So you can go with 3 or 5. But I went 5. Okay. So in 5, how many times of 5s are there in 45? 9 times. So I am going to write 9. And the same number, which number used to divide the value 9? As 3 table. It is coming in 3 table now. So write 3. And how many times are 3s are in 9? 3 times. The same number. It is a prime number. So use the same prime number to divide the values. So 3 and 1. Finally, you have to take and write all those things. 48. How many 2s are there? 4 2s and 1 3. So you have to take and write at last. 48 equal to 2 into 2 into 2 into 2 into 3. So write down like that. And 54 equal to 2 into 3 into 3 into 3. And 90 equal to 2 into 3 into 3 into 5. So now we are going to circle the common factors. Here all the numbers having 2. 48 4 times of 2s are there. In 54 only 1 time and 90 in only 1 time. So only 1 time, 2 numbers having only 1 time of 2. 48 alone having 4 times of 2. So I am going to, only 1 is common for all those numbers. So I am going to circle 2 alone. Okay. So these are, the 2s are common. And next thing, 3. 2 over, then 3. Go with the 3. Here one type of 3 is there in 48. In 54, 3 times are there. In 90, 2 times are there. So, but in 48 alone having only 1 time of 3. So, I am going to circle only 1 time of 3. 3 here. Okay. So, then remaining and are not having common factors. So, whatever we circled, that number you take and write. The common factors of 48, 54 and 90 is equal to which and all 2 and 3. Okay. So while finding the HCF, you should multiply the common factors. Okay. I mean product of common factors, that is HCF. So HCF of 48, 54 and 90 is equal to 2 into 3. We want to multiply these two common factors. 2 into 3 is equal to 6. And then the next concept, to find the HCF of the following by long division method. We have studied the HCF to find the HCF using prime factoration method. Now we are going to find the HCF by using long division method. I am going to explain through example. One of the example is given for you, 72, 192. We are going to divide these two numbers. So which number we want to write inside, which number we want to write outside, I am going to tell. Which is the smallest value here? 72. So that we want to write outside. And which is the greatest one? That we want to write inside. So first number is the divisor, second number is the dividend. So you have to write on like that, 72 outside and 192 inside. Now how many 72s are there in 192? That we are going to find. So write the multiplication table aside. 172 is 72. 2 72s are 144. 3 72s are 316. It increases than the dividend. So you have to take less than the dividend. Which number is less than the dividend? So here 2 times are there. That 2 we want to write top and write 144 right at the bottom. Then while dividing the two values, we want to subtract the two values, isn't it? So we want to subtract the two values, you will get finally 48. Okay, you subtract the two values, you will get 48 remainder. That remainder, now we are going to use this remainder as a divisor. Okay, so the 72, that divisor is now that divisor to become divided. So the 72, it will come inside the bracket, and the remainder that used as a divisor. So bring 72 inside. Okay, the first divisor convert into dividend. Okay, so 72 you want to bring it inside, and the remainder we are using as a divisor. So how many 48s are there in 72? So again you want to write the multiplication table. 1 48s are 48, 2 48s are 96. But it is increasing the value. So how many times are there 48 in 72? Only one time. So write 1 at the top and write 48 at the bottom. You have to subtract the two values. 72 minus 48, you will get 24. So you are getting remainder. So that remainder use as a divisor, and the previous divisor now that use as a dividend, which is that 48. The 48 you have to bring it inside. Okay, the 48 you have to bring it inside. So 48. The 48 become that divisor become dividend. Here remainder becomes divisor. So now we are going to divide these two values, 24 and 48. In 24, how many 24s are there in 48? So again you have to write the 24 table. 1 for 24s are 24, 2 24s are 48. You are getting the answer 48, isn't it? So how many times are there? 2 times are there. That 2 you want to write at the top, then 48 write at the bottom, then subtract the value, you get 0. Up to, you have to divide the values, you are getting up to 0 remainder. So first divisor convert as a dividend. Okay, then you are getting the remainder, that is convert as a divisor. Then you are getting the remainder convert as a divisor. So last divisor, what you get? Which divisor used to get the 0 remainder? Only 24. Okay, that is the HCF. So the last divisor is the HCF of 72 and 192. So the HCF of 72 and 192 is equal to 24. The 24 is the last divisor. Okay, have you understood that? The next one example for you. In this example, I am going to give 3 numbers to find the HCF by using the long division method. The previous sum we have learned 2 numbers alone to find the HCF. Here 3 numbers are given. Yeah, I am going to explain through that. 264, 840, 384. So we are having 3 numbers. I am going to select first 2 numbers, the 264 and 840. Okay, so the which is smallest that we want to write inside the bracket, and which is greatest that you want to write outside the bracket. So I'm writing that like that. Now I'm going to divide the values. So once again you have to write the 264 tables here. So 840 where it is not having, we want to select less than 840 or equal to 840, but we are not having equal to 840. So less than 840 alone we want to take. Which things? Third one. So 3 times are there. So write 3 at the top and write 792 at the bottom. Then subtract the 2 values. You will get 48. And then that is remainder. You are getting remainder. That remainder uses a divisor. The first divisor uses a dividend. So you have to bring 264 inside. Okay, now we are going to divide the values. 48, how many 48s are there in 264 means 5 times are there. 240 you are getting. Okay, so you have to subtract the 2 values. If you subtract 10 means you will get 24. Okay, so then what do you want to do? 24 you have the remainder. So the next divisor, what is that? 48. That 48 you have to bring as a dividend. So bring it inside 48. So now how many 24s are there in 48? 2 times are there. So write 2 at the top, write 48 at the bottom. Then you subtract the 2 values, you get 0. So you are getting 0. Which number used to divide to get 0? The last divisor, what is that? 24. So that 24 is a divisor. I mean that 24 is a HCF. Okay, the last divisor is the last divisor, no, that 24. That 24 is the HCF of 264 and 840. So, the HCF of 264 and 840 is 24. Now, we are going to find the HCF of 24. What we get the HCF 24? No, that 24 and remaining we have one more number, 384, third number, that we are going to use to find the HCF. So, which is the smallest one? 24, that we want to write outside. Which is the greatest value? That we want to write inside. So, write on that 24 outside and 384. So you are going to divide the values. First 38 you are taking. How many times of 24s are there? 38. Only one time, write 1. Write 24 at the bottom. Then subtract the two values. You will get 14. Then remaining you have 4. That you have to bring it down. Then how many times are 24s are there in 144? 6 times are there. So 6 are right at the top. Write 144 right at the bottom. Then subtract the 12, you will get 0 remainder. So which is the HCF of these three numbers? 24 is the HCF. So 384 is divisible by 24. So the HCF of 264, 840 and 384 is equal to 24. Have you understood that? Start to write math classwork. Take your math classwork note. Draw margin, write date, everything. Already we have completed up to co-prime numbers. So continue from that. Prime factoration. When a number is expressed as the product of its prime factors, we call it prime factoration. There are two methods of prime factoration. One of the method is factor tree method. Next one, short division method. Then we are going to write factor tree method. Formula 1, find the prime factoration of 450. So write down everything that. Take snap and copy everything in your math classwork note. Then prime factoration of 450 is equal to 2 into 3 into 3 into 5 into 5. Then second sum B, 256. So write down that. So all the composite number write inside the box. All the prime numbers should write inside the circle. Here I have no space to write for expanding 8. So I bring it separately. Then prime factorations of 256 equal to 2 into 2 into 2 into 2 into 2 into 2. Totally we have 8 2's are there. If you multiply all the 8's, you will get 256. Then short division method, write on the heading black in color and open it to find the prime factoration of A, 216. So write the short division method. Only one example I gave how to divide the values. So like that you want to do every steps like that. Then prime factoration of 216 equal to 2 into 2 into 2 into 3 into 3 into 3. Then B, 75. If we divide 75, we get the prime factorations of 75 is equal to 3 into 5 into 5. So take snap and just copy in your math class of note. Today's homework for you. Chapter number 6, page number 34, exercise number 1, first sum AB, third sum, fourth sum A to D, page number 37, exercise number 2, 1 to 7, complete in the book itself. Today, you want to write classwork as well as homework part. Thank you children. Thank you parents. We will meet in the next class.